Here we come to the fourth rule for the differentiation technique. So the fourth rule will be a product rule. So as the name suggests, it's meant for a product. So we actually label the product as U and V. So there's actually a condition. So there is a condition that that needs to be satisfied, then we can be using this product rule. So the condition will be the function here, there's a product multiplication, and both product must contain X. Both products must contain X. So the first item must contain X, the second item must contain X. So what if one of the item doesn't have X? So we do not need to use the product rule already. So if this condition is not satisfied, so that means, right, maybe it is a number multiplied by a function. So in this case, if it's a number multiplied by a function, we may end up using chain rule. So in order to use the product rule, you need to make sure that the product contain X. So a lot of people, they are not aware, or they will tend to forget. Then they will be like, so when do I use this? When do I use chain rule? So we'll use this when if there's a product and the first function contain X, the second function also contain X. And we will treat the first function as U, we will treat the second function as V. So we will have it in UV formats. Don't try to change the alphabet. So this will be the formula. So this will be the formula. So it will be easier if I use a numerical value to explain. So if you, where we comes to the product rule, there are two cases. So the two cases, let's observe. Under case one of the product doesn't have square root. So if you look at this situation, so let's explore this one. So this bracket is multiplied to this bracket. So can you see both item contain X and there is no square roots. So in this case, right, what you can do is the first one will be U, the second one will be V. So it's kind of like first come, first serve. So I actually do some mini differentiation first. So the mini differentiation looks like this. So this is my U. U is equal to X minus 1. This is my V. So we will kind of differentiate them separately. So the notation, take note, this is UX. So you will be getting a du dx. So please take note of the notation, or else you'll be very confused. How do you even plug into the formula? So the notation will be du dx. You will use the rule. This one will be rule number 2. This one will be rule number 1. Okay, so that is a bit like you differentiate the first product. So the first product, when you differentiate, you get what we call du dx. So the second product is x plus 2 squared. So when I was going through the chain rule, when I just started the chain rule, I mentioned that it's meant for a function with a power. So in this case, this power is 2. So actually this power is 2, you got the option. Do you want to expand or not? Both are quite easy lah. So in this case, right, you just do a bring down power, minus power, and if you are going to be differentiating the x plus 2, this will actually give you a 1 plus 0. Because differentiate x is 1, then differentiate 2 is 0. So the third layer actually reduces to 1 plus 0. So essentially, I'm just getting a 2 with a bracket. So by now, maybe you already can mental this. Okay, so after this, let's clean up a little bit. How do we make it into the product rule? So where is the product rule? This is the product rule. So if you look right, the function u is multiplied to dv dx. So you take this function, multiply with this function. So you take the function for u. So this is u. This is dv dx. So that is for the first part of the product rule. For the second part, it will be a v, the function v, and then the u dx. So where is your function v? So this is your function v, and then you multiply to the u dx. So this is my v, and my du dx is a 1. By now, your differentiation is done. So this is the differentiation portion. After the dotted line, right? You already done the differentiation. After the dotted line, no more differentiation. So what comes after the dotted line? It will be your simplification. How do you simplify the expression? So in the case where there's no square root, the technique usually will be take out common factor. Okay, so in case some of you, right, usually I got people who didn't understand how to take out common factor here. So let me rearrange a little bit. You take a look. There is a x plus 2 with a square. So it's actually a x plus 2, x plus 2. So where is the common factor that I'm talking about? So the x plus 2 is a common factor. So this is the common factor. So I'm left with 2x minus 2, which is this portion, plus the other bracket. So after I take out the common factor, this is what I've gotten. Then you take a careful look. So this part is a common factor. You simplify this bracket. 2x minus 2 plus 2 plus x. So you will cancel and you're left with 3x. So some students, they couldn't get the answer, but it's not due to the differentiation. So they actually got everything correct until the dotted line. So they make the mistake in the simplification. So they find it challenging to simplify the algebra. So there are two possible mistakes. It could be a differentiation mistake or it could be a simplification mistake. So sometimes when you make mistake on the product rule, you got to be clear. So what was the mistake? So let's explore the second option where there is a square root. So the first product, u, the second product, v. So both contain x. So write your function and apply your formula. So you will get your du dx. So that is the mini differentiation. So do the function. So if there is a square root, you got to change it to power half. Then I'll be using the chain rule. So there will be 3 steps. Bring down power minus power. So by now, maybe you can differentiate the function inside. So the quadratic function. So this will be rule number 2, and this will be rule number 1. So the 6x came from the part where you differentiate the function that is inside. And in this case, the function that is inside is a quadratic function. Then, okay, then the next part is the challenging part. A lot of students, do not simplify just because they don't like. So it is a must for you to simplify. So you must simplify into a square root. So you must simplify. So how would you simplify that? So half and 6x will make up the numerator. So this part should be 1 over 3x squared plus 1 with a half. And power half is how I gotten the square root. So you must simplify your mini differentiation. So most people, they couldn't do due to the fact that they don't simplify into the square root. Okay, so let's tidy up first. So you must simplify the part with the square root. So this part is the must. It will facilitate the product rule. So the product rule is like this. U dv dx v du dx. So you take this function and you multiply to the nice fraction that you have. So this is the u, this is a dv dx. Then the other part is a v. So I'm going to take the function for v, multiply to this. So this is a power half. So this part here is du dx. This part here is the function v. So once you put the component into the product rule, so don't forget, this is the product rule. Anyway, this formula not given to you. You got to be doing the differentiation at your fingertips. So again, I put a dotted line for you. The differentiation is done already. So how are you going to simplify? So just now in the case with no square roots, you simplify by taking out common factor. Here, we actually got a nice fraction. So here we actually got a nice fraction. This function follow the numerator. And I got a nice fraction. So the other one that is not like a fraction has the invisible denominator one. So here I will try to multiply the function. I'm trying to make same denominator. Because after I try making same denominator, I can combine to a single fraction. So the square root here and the square root actually cancel out. So once you combine into a single fraction, okay, it's just simple algebra. And that will be your product rule. Okay, so there are only two scenarios. One of them may contain square root or both of them can contain square root. So in the case where they got to contain square root, you must do your mini differentiation and simplify into a fraction. And then the technique is usually make same denominator compared to the type of product rule where it doesn't involve square root. The technique will be take out common factor. So if you stay with these two, it should be, you shouldn't have quite a lot of mistake. Okay, so it's just these two type of question for product rule. So again, the condition will be the bubble, the product must both contain X. So if one of them doesn't contain X, right, please don't use product rule. We will go back to our chain rule.